Graph x squared equals negative 6y. Identify and label the focus, directrix, and endpoints of the lattice rectum. Okay, this time we have x squared equals negative 6y. According to our table, the x squared function has an axis of symmetry, which is the y-axis. That means it's going to be a vertical parabola. So we have x squared equals 4 times something y. Well, if we need to figure out what goes there, let's just create some variable. We know that it's supposed to be x squared equals 4py, right? So 4p has to equal negative 6. 4p has to equal negative 6. If we divide both sides by 4, we get p is equal to negative 3/2. That means p is negative 3/2. The focus, according to our table, the focus is 0p. That's going to be 0, negative 3/2. We're looking for the directrix. The directrix is going to be y equals negative p. Well, that's y equals the negative of negative 3/2 is a positive 3/2. This is your directrix. They want the endpoints of the lattice rectum. Endpoints of the lattice rectum. That's going to be plus or minus 2p, p. So we're going to have plus or minus 2p. So 2 times p is going to be negative 3/2. The 2's cancel and I end up with a negative 3. When I have plus or minus a negative, I still end up with plus or minus, right? So that's going to be plus or minus 3 and p, which is negative 3/2. These are the endpoints of the lattice rectum. So let's start graphing all of this stuff. We have the point 0, negative 3/2. 0, negative 3/2 is negative 1.5. So we'll put that in here, 0, negative 3/2. The directrix is at y equals 3/2. So here. And the endpoints of the lattice rectum are at plus and minus 3 and negative 3/2. So we're going to go to 3, negative 3/2. And we're going to go to negative 3, negative 3/2. Our vertex is, of course, at the origin, and the parabola goes through those endpoints. I always put numbers right where I need to draw. And there we go. Our axis of symmetry is the y-axis. So if you're asked for it, the axis of symmetry is the line x equals 0. And the origin, or the vertex, is the origin.